This one is January 2018, Unit 6. First, we'll discuss some questions from this unit and then explanation of Unit 5. A student makes a measurement to determine the density of a steel. The student has a disc and it is made from a steel with a thickness about 1 millimeter. The student used a vernier caliper to measure a diameter of the disc, and he measured a diameter several times and calculate the mean or average. State why the student should take several measurement and calculate the mean. So why we should always repeat the experiment and take an average. So whenever we repeat the experiment, we minimize the random error. And maybe the object may not be uniform, like some part it will have a greater thickness than the other parts. So repetition will always minimize the random error. Or the diameter or the mean may not be uniform. That's why we have to repeat and take an average. He measured the thickness of the disc using a micrometer screw watch and record the following. So 1.58, 1.52, 55, 54, 56. Calculate the mean. So how we'll calculate the mean? We sum then divided by the total. So we will just add them. It will be 1.58, 1.52, 1.55, 1.54, 1.56, and then the total will be divided by 5. That will give us the mean or average, which is about 1.55 millimeter. Then calculate the percentage uncertainty. How to calculate the percentage uncertainty whenever you have a group data? The formula, first we get the uncertainty. Uncertainty is maximum minus minimum divided by 2. That's the uncertainty of a group data. And percentage uncertainty, that is the uncertainty divided by the mean or the average into 100. So first we calculate the uncertainty, which is maximum value 1.58 and the minimum value is 1.52. So maximum minus minimum, so 1.58 minus 1.52 divided by 2. This will give us the uncertainty. And then uncertainty, like after getting the uncertainty, which is about 0.03, this one. So uncertainty in the measurement is 0.03. Then to calculate percentage uncertainty, 0.03 divided by average 1.55 into 100. So the percentage uncertainty is 1.94. Is it clear? How to work out the percentage uncertainty from a group data? Then calculate the mean value of a volume of a disk. So how we can work out the volume of a disk? We have the diameter and the thickness is there 1 millimeter. So this is 1 millimeter thick and we have the diameter. So using a diameter, we'll find the area and area multiplied by thickness, we'll get its volume. So volume is pi, because it's a disk, so pi r square h or pi is, so pi is there 3.14. Radius will be half of the diameter. So when we calculated the diameter, it was coming out as the mean or the average was what was there 1.55. Or diameter is given in the first part. But that's the thickness, average thickness. So yeah, diameter is there 35.2. every thickness one. So this was 35.2 divided by 2, but that is in millimeter. So 35.2 divided by 2, we'll get the radius, and we have to convert the millimeter into meter. So it will be 10 is power minus 3, and then we will square. And then the average thickness was 1.55, which we calculate, but that was also in millimeters. So we convert into meter, we divide by 1000 or 10 to the power minus 3. When we multiply all of them, this will give us the mean volume or average volume, which is about 1000. Or if you don't convert the unit, like example, if you don't want to convert the unit, then the final answer will be in millimeter cube. Like if we just to get the diameter radius, it's half of diameter, 35.2 divided by 2, and then square, and then multiplied by the thickness. The thickness was how much? It was 1.55. So we multiply 1510 millimeter cube. That will be the average volume of this disk. The next one, calculate the percentage uncertainty in mean value of the volume. How to calculate percentage? Because how volume is calculated? Volume is calculated by using a formula uh, like V is equals to pi r square h. And whenever quantities are multiplied or divided, we first find the percentage uncertainty and then we take a total. Now, what will be the uncertainty in value of R? And now how R is calculated, it's like half of a diameter. So it will be d by 2, or we calculate it by using a formula pi. In place of R, if we write half of diameter, so d by 2, and it will be pi d square by 4h. So volume is equals to pi d square by 4 and h. Pi and 4 does not have any uncertainty. Why? Because these are constant. So means we'll find the percentage uncertainty in d square, and we have the percentage uncertainty in the thickness. We'll find the percentage and uncertainty in both of them and then add to get the percentage uncertainty in volume. How to get the percentage uncertainty in diameter? So diameter, when we measure a diameter, what was given, the uncertainty in the measurement of a diameter was 0.1 and the diameter was 32.5. So uncertainty was 0.1 and it was 35 point, the value which we record, the uncertainty. So that was 35.2. And this is the uncertainty in diameter, but in percentage uncertainty in diameter square, so it will be twice. Why? Because when a power is 2 is there, so it will be twice. If power 3 is there, it will be 3 times. And then into 100 to get the percentage. So the percentage uncertainty will be 0.568% in diameter square. And in the percentage uncertainty in the thickness, which we already calculated, which was 1.94%. Now, what is the total uncertainty in measurement of the volume? Because the volume is measured by pi d square h over 4. So the uncertainty is due to d square and h. Uncertainty in d square is 0.568 and in h it was 1.94. So the total, when we sum, we will add them, that will be 2.51%. So 2.51% is the total uncertainty in the measurement of volume. Then student use an electronic balance to measure the mass of a disk and as 11.96 with a negligible. Calculate the density. So how to work out the density? Density is mass over volume. We got the average volume of the disk and we have the mass, so we just divide them. So density is mass over volume. The mass is 11.96 and the volume was 1510 millimeter cube. And this was gram. So our final answer will be in gram per millimeter cube. But so if you write in gram per when you divide it, you will get at 7.92 gram per millimeter cube. Or you can also convert millimeter cube into meter cube and then get the density in kilogram per meter. So if we convert into kilogram per meter cube, 7.92 we multiply by 1000. If we want to convert gram per millimeter cube to kilogram per meter cube, we just simply multiply by 1000 and that will give us 7920 kilogram per meter cube. Then there are different types of steel. The density of a carbon steel is 7860. Determine whether the disc could be made from carbon steel. So what we have to do, we have to compare the percentage difference with percentage uncertainty. So percentage difference is a maximum minus minimum divided by mean into 100, or maximum minus minimum divided by standard into 100. That will give us a percentage difference. And then we'll compare with the percentage uncertainty. If the percentage difference is higher, then we'll say no. If the percentage difference is less than the percentage uncertainty, then we'll say yes. So percentage difference, if we have the standard value, the maximum value for us when we calculate, it was 7920 minus minimum 7860 divided by the standard into 100. So that will give us 0.763%. That's a percentage difference. And percentage uncertainty, when we calculated, that was 2.51%. So percentage difference is less than percentage uncertainty. So we will say, yes, two values are same, or this. So it's always a comparison between percentage difference and uncertainty. If percentage difference is smaller, then we'll say yes. If it is higher, then we'll say no. Then in question 2, a student is asked to determine the value of G using a simple pendulum, where T is representing a time period of the oscillation. T is equals to 2 pi under root L divided by G. The student uses a stopwatch with a precision of 0.01 second to time the oscillation. What is meant by precision? So what we refers to precision, precision means like the smallest measurement which we can, like a smallest value which we can measure by using the instrument, that's called its precision. Or also refers to uncertainty of the instrument. So as I mentioned, uses stopwatch with a precision of, so what is the meaning of precision of stopwatch to be 0.01 second? It means it's the smallest value which the instrument or apparatus can record. Then you have to write a plan. Whenever a question is there in which you have to plan experiment, try to answer each question separately, each part separately. Write a plan of an experiment, determine the acceleration due to gravity or the value of the G using a graphical method. So you should be able to plot a graph. A diagram of apparatus showing the length can be measured. So how we can measure the length if we want to determine, because the formula we are using, T is equals to 2 pi under root L over G. And we want a diagram of apparatus should show how a length of a pendulum can be measured. So we clamp the pendulum, and length of the pendulum is always from center of the mass to the point where we hang. So from the point we clamp till the center of the mass of the bob, and this is refers to length of pendulum. And how we can measure accurately as possible, so a meter rule or a meter scale should be placed close to that, and we can use a set square, look perpendicular, and avoid parallax error to measure this value accurately as possible. The second part, so you have to draw for part B1, you have to draw this one source of uncertainty in measurement of the time. So when we are measuring a time interval, what is this one source of the uncertainty? Mainly the reaction time is there, because what happen as a pendulum oscillate or vibrate, and you want to record a time for one complete oscillation. One complete oscillation means the time it will move from one extreme position to another and then return back. So when it will, like you start from here, you release the pendulum, it moved to other extreme position and then it returned back. That is the total time it take, refers to a time period or period of oscillation. So what is the difficulty in measuring the period of oscillation, as we are using a stopwatch? So whenever experiment involve a stopwatch, so there is always a reaction time in measurement. Like you think like you should stop the timer so that you will take time to react, and that time interval is also added in a time period. So it's always a reaction time. So stopwatch experiments, reaction time is always leads to uncertainty. A description of how an accurate value of a time can be determined. So how we can measure a time accurately as possible. So we cannot overcome this reaction time, but we can reduce the percentage uncertainty. What is the percentage uncertainty? That is the uncertainty divided by the value recorded into 100. So instead of recording a time for one oscillation, we can record the time for 20 oscillations. And that the total time which we record divided by number of oscillation will give us the time period. So if we record a higher value, then it will minimize the percentage uncertainty. So mention description of how an accurate value of the time can be measured. And it's a 4 marks. So how you score the 4 marks? So first thing, you will mark fiducial points or mark mean and extreme position. That is one thing, because you can identify. Then you will release the pendulum and record the time for 20 oscillation, then divide the time recorded by number of oscillation and repeat the experiment. That's how you score the 4 marks. Then the graph you would plot and how you use your graph to determine G. So how we'll determine G? Like we have this value T is equals to 2 pi under root L over G. That's the equation. How we can use this equation to plot a graph? So T equals 2 pi under root L over G. If I square this equation both sides, so what I will have T square is equals to 4 pi square L by G. Now, if I plot a graph between, and I compare with the equation of straight line, y is equals to mx. On y-axis, if we have t square, the time square. So on y-axis, we have time square. On x-axis, if we plot length, and whenever you label the axis, it should be with column headings. So the unit of the time square will be second square, and the unit of the length in meter. So what will be, because there is no y-intercept, so means it should be a straight line. It should start from origin. And how we know it should be a straight line? Because the gradient is 4, which is constant, pi square, which is constant, and g is also constant. So the graph between the t square and L will be a straight line passing through origin. And if we want to work out the value of a g will be equals to 4 pi square divided by m, which is a gradient. So 4 pi square divided by the gradient will give us the value of acceleration due to gravity. So this was a experiment question from Jan 2018. Next session we'll do more from this.